Swayam Prabha. Digital India. Educated India.
Welcome friend, welcome to the course Analysis of Variance and Design of Experiments. So now from this lecture we are going to begin a new topic, that is about the experimental design and their analysis. Now if you can recall, what are you doing in this course? You wanted to learn what is the design of experiment. But what you were doing up to now? You simply conducted and developed some test statistics for testing different types of hypotheses, multiple comparison tests, etc. So now the question is this: why we have learned all those things and what are we going to do? Although I had explained you in the beginning of the lecture, but now I will just give you a quick review of what we had done. In case if you recall, in the beginning I had told you that when we are trying to talk about this course Analysis of Variance and Design of Experiment, so this course has two components. One is the analysis of variance and second is the design of experiment, and both these topics are complement to each other. How? You see, you have now developed some test of hypothesis. You have found that there is a statistics which follows a chi-square distribution, F distribution, and this is how you are going to accept or reject the hypothesis. But the question is, on which data set you are going to accept or reject the hypothesis, and what is the data on which you are going to apply it. So that is why there are two components. One is the collection of experimental data, and second is the application of those statistics that you have developed for testing particular types of hypothesis. So that is why when we are talking about the topic of design of experiment, then this topic is going to explain us how are we going to collect the data. And once you have got it, then definitely, as we say in statistics, that the data is deaf and dumb. Data cannot speak itself, but data has got lot of information. So now how to bring that information from inside the data by using what type of tools, that is an issue. And for that, now we already have developed some tools, like as one-way analysis of variance, two-way analysis of variance with and without interaction, and multiple comparison tests, and we also have now learned how these tests are developed. They are not coming from sky, but they are based on some pure statistical concept and statistical theories. So now we have completed that part, that we have developed the required statistical tools which are going to help us in taking out the information from inside the data. Now the next question is, how are we going to get the data and why? So now you see, in statistics, what really do you do? You have something in your mind, you know something, you observe something, but you don't know what is the conclusion which is going to be accepted by each and every one. For example, if I say in my class, I am going to give, say, first class to those students who are wearing a sky blue shirt like me, and second class to those who are wearing a white shirt, and so on. Are you going to accept this thing? No. Well, the reason is that this is not the scientific way, and this is not really reflecting the academic capabilities of the students. So, now my objective is that we want to understand the academic capabilities of different students. So, what we try to do? We try to give a course, then we try to ask some questions based on that course, then we get some scores based on those tests, and then we say, okay, if anybody is getting, say, more than 60% marks, that student will be classified as first class student. Anybody who is getting, say, between 45% and 60%, that student can be classified as second division student, and so on. And then you believe on this. So, now the question is this: if I try to simply translate in a very simple words, that in order to know the academic capabilities of the student, you conducted a test by giving some examinations like as quizzes, mid-semester examination, final examination, quarterly examination, half-yearly examination, and you are trying to repeat it. If you try to see, sometimes you have seen that in the courses that we say, okay, we are going to conduct, say, 5 say exams, and we are going to consider 4 best marks. Why are we trying to do it? Just think about it. Why can't I say that, okay, in case if I want to discuss the academic capabilities, I will ask my students to participate in a race, and that student who wins, that student will be called as a first class student from the academic point of view. Or say any student who completes the race in, say, 20 seconds or 30 seconds, I will classify the student as a first division. You will not accept it. So, that means, you know, when I want to judge the academic capabilities of the students, how to get it done, right? And now you are trying to execute this phenomena in a particular way. You try to take the students who are enrolled in the course, you try to give them some lectures, you ask them to read from the books, and after that you try to ask some questions which are based on that course only, and then you try to grade them, and based on their marks you are classifying them. What is this? If you try to think, what are we doing? And if I say, I simply designed an experiment to know the academic capabilities of my students, don't you think so? So, now you can understand this topic of design of experiment is a very simple thing, and which we are trying to execute each and every day in our day-to-day life. The only thing is possibly you have not understood that what are you really doing from the statistical point of view. So, now let me take here one more example. Suppose there is a new medicine, and this medicine claims that it can control the body temperature, or if some patients have got fever, then if this medicine is given to that patient, then the body temperature will come down, say, in 3 hours of time. Now, the question is this: how do you know? So, what are you going to do? You are going to administer that medicine to a group of patients who have got the fever. Now, when you are trying to give that medicine, then the question comes that what is the dose that you have to give? For example, you have seen sometime in the medicines, it is written on the label of that bottle or the packet of that medicine that okay, for those who are between the age of say 5 to 12 years, they have to be given 1 tablet. Anybody who is more than 12 years, they have to be given 2 tablets, and so on. So now you understand that by giving different doses of the medicines, the effect is going to be different. But my question is, how do you came to know? Who told you? And how that person who has printed this details on the box of the medicine, how that person came to know? So now you have an objective. You want to know what is the effectiveness of this medicine with respect to different dosage. So now you have here two options, that you try to take a certain number of patients who have got the fever, and you simply try to give them the medicine, 1 tablet to some patients, 2 tablets to some patient, and try to observe the data. And based on that, you try to do something, apply some statistical tool to find out that whatever you were thinking or whatever was your hypothesis, is that true or not? Now, in case if I try to reconsider this experiment once again, then first you will try to take a call that what are the different dosage of medicines. This is 1 tablet, 2 tablet, 3 tablets, etc. So, suppose we take a call that there are 3 dosages, 1 tablet, 2 tablet, 3 tablets. What are these? These are simply your different levels of the factor, and your factor here is doses of medicines, and your outcome here is the, for example, that duration in which the body temperature comes to normal. So now you have fixed the different doses of the medicine, and they have to be given to different patients who have got a particular type of fever. Now you can conduct this experiment in a different way. Suppose you believe that the doses of medicines are going to be related with the age of the patients. So what you try to do? You try to, for example, divide your patients into 2 groups, say young children and elder people. So you can say that okay, all those whose ages are less than 12 years, they are going to be considered as young children, and all those patients whose ages are more than 12 years, they are going to be considered as elder. Now what you will do, that if you really want to know the effect of that medicine in terms of the doses of the medicine, you will try to give different doses of medicines to different patients of different ages. So now here if you try to see what you have done, you have considered here 2 factors. Factor A is the dose of medicines, and which has 3 levels, 1 tablet, 2 tablet, 3 tablets. And the factor B here is the age of the patients. So for that you have 2 levels, all those patients whose ages are below 12 years and all those patients whose ages are more than 12 years. Now what you will do? You will try to give different doses to different age groups, and you will try to conduct an experiment by giving or by considering different combinations of the doses of medicines and the age of patient. For example, you can give 1 tablet to young children and 1 tablet to elder people. Then you will try to give 2 tablets to young children and 2 tablets to elder people. And similarly, you will try to give 3 tablets to young children and 3 tablets to elder people. But your observation is the same, that you are simply trying to observe that how much time has the medicine taken to bring the body temperature to a normal level. So, now you can see here we have here two types of cases or the way in which you have conducted the experiment. In the first approach, you simply considered only the doses of the medicine and you have not considered the age of the patients. And in the second case, what you have done? You have considered two factors. One is the dosage of the medicine and second is the age of the patients. Now, what you want to know? You simply want to know in the first case whether the effect of 1 tablet, 2 tablet and 3 tablets on these patients is the same or different. That means different doses of the medicines, do they affect exactly in the same way or in a different way? So, you might see that if you are trying to give only 1 tablet, the possibly the time taken by the medicine to bring the temperature to a normal level may be higher, and when you are trying to give 2 tablets, then the duration becomes smaller. And similarly, if you try to see the effect of different ages and different doses of medicines, you can see that okay, if you are trying to give 1 tablet to young children, that has got a different impact, and if you are trying to give 1 tablet to an elder people, that has got a different impact. So, now you can see here, what do you really want to check? You want to check two types of observations or two types of hypotheses actually, that the effect of the medicines for 1 tablet, 2 tablet and 3 tablet, are they the same, and the effect of different doses with respect to different age groups, are they the same? So, now you have here two hypotheses, one for the different level of medicines and second hypothesis about the different levels of the dosage of medicine. Now, the question is how are you going to verify it, because you have got the observations in both the experiments only on the outcome. In your common language, the outcome is indicated by Yij. So, now if you try to see, if you want to conclude something in the first case where you are trying to take only one factor, that is the doses of the medicine, can't you use the one-way analysis of variance? And when you are trying to consider two factors, that is the doses of the medicines and the age groups, don't you think that you can very well apply here the two-way analysis of variance? Well, that depends, that whether you want to have interaction or not, that is up to you. So, now if you try to see, now this is a combination, that in order to verify or to know certain outcome, or you wanted to verify the effectiveness of the medicine, you have conducted an experiment. You have got the observations. Now, from those observations you want to verify the hypothesis which you are thinking, is this getting accepted or not? So, now whatever the statistical tool is needed here, either one-way ANOVA or two-way ANOVA, that we already have developed. Now, you do not need to worry for that part. So, I will say simply you conduct the experiment. In the first case you apply one-way analysis of variance, and in the second case you simply apply the two-way analysis of variance, and that is all. Based on that you can conclude and you can finally divide the different effects in different groups, so that within group the effects are the same. You can use multiple comparison test also. So, what is this? This is simply design of experiment, and you have conducted this study in a systematic way. Well, in case if you want to see the effectiveness of the medicine, you have not asked your patient to participate in a race and try to say walk or run for 2 kilometers, and if they are coming to the destination in say 15 minutes, you say the medicine is effective, otherwise not. You have not done it. So now everything is clear to you, because I feel that once I ask you a question and you say no, that means you also know what is right. So if you cannot judge the effectiveness of medicine by asking the patients to participate in a sports activity, then I believe that you also know what is correct. So in the first case, when I tried to conduct an experiment, there you agreed that this is the better way. So now, design of experiment is simply an approach to find out the answers, replies, queries on the basis of given set of data in a proper way. Now, what is called proper, that we will try to see. And based on your objective, you are trying to conduct the experiment. Means when you believe that doses of medicines are not dependent on the age, then you conducted one-way analysis of variance. And when you believe that the doses of the medicines and age groups, they are not independent, they both are going to affect the outcome, then you conducted the two-way analysis of variance. Right. So that is as simple as that. Now you see, when you develop the one-way analysis of variance and two-way analysis of variance, you made certain assumptions. For example, you always assume that Yij's, they are independently distributed, they are following certain mean, they are following certain variance, they are following certain probability density function. For example, we assume that Yij's are following a normal distribution with certain mean and certain variance. So now, the question is, if you want to use here the one-way analysis of variance or two-way analysis of variance for the analysis of your data, that unless and until this data is going to satisfy these assumptions, you cannot use the analysis of variance tools. For example, you assume that Yij's, they have got a constant variance, or if I say you have got different samples from different normal population whose variances are different. Now, do you think that you can apply the one-way or two-way analysis of variance that we have developed in the earlier lecture? No, because we assumed that we have got different samples, but the parent population has got the same variance sigma square, and the populations are differing with respect to only with the mean. So now, when you are trying to conduct the experiment, you have to ensure that the way you are going to draw the samples, they have to be independent, and they have to be drawn from such populations which are varying with respect to only the mean, not with respect to the variance. Now, the question is how this can be done, how this can be achieved. So, for this, we try to conduct the experiment in a particular fashion, in a particular way, and we always try to keep in mind that whatever are the basic assumptions which are needed for the application of the required statistical tool, all such assumptions should be satisfied by the experimental data. Well, in such a case, the data is coming from an approach which you are trying to inform, or the approach which you are trying to determine, or the approach which you are saying that okay, this is the way by which you have to get the data. The second thing is this, okay, there is a natural process, you simply try to collect the data in a natural way, and then you try to conduct the statistical analysis. So, in this case we are going with the first option, that you are trying to get the data in the way you want it. For example, you know that one tablet of medicine is to be given to elder people and 2 tablets are given to the younger people. So, that is your choice, but this choice has to be controlled by some statistical laws. So, the way you are trying to get this data or the approach which you are trying to implement so that you get here a data on which you can apply the tools of analysis of variance, including the multiple comparison test, that is simply called as design of experiments. That means you are trying to design an experiment so that you get a valid inferences after the analysis of the data. So, now you can see this designing of experiment is a very simple thing. It is not a very complicated thing, but it depends on your objective and it depends what you really want to know. For that you have some idea. For example, nobody will come from sky to inform you that okay, in this case you have to go for one-way analysis of variance and in this case you have to go for two-way or three-way analysis of variance. This is only you who is going to take a final call that you want to use here one-way, two-way, three-way or any other type of analysis of variance, and first you take a call and then you try to conduct the experiment so that the required data is satisfying the basic assumption of the statistical tool which you want to apply to obtain the valid statistical inferences. And once you get an inference from such a scientific approach, people are going to believe on it. Once you conduct a clinical experiment and if you try to say okay, for children you can give only 1 tablet and for elders you can give 2 tablets, everybody is going to believe on it, it is going to be printed on the box and everybody will follow it. So, this is design of experiment. So, now definitely if you want to apply the one-way analysis of variance, the method approach is going to be different to collect the experimental data or the way we want to conduct the experiment, then when we want to apply two-way analysis of variance or even when we want to apply two-way analysis of variance with the interaction, then we know that unless and until we have multiple observations on a given combination of the treatment, you cannot find out the variance and the interaction effects. So, this is the theory and the idea behind the design of experiments. So, now based on that we have different types of designs of experiment, and in this course we are going to discuss couple of designs of experiment, say completely randomized design, randomized block design, Latin square design, balanced incomplete block design, etc. And these designs are going to be used under a different setup. So, now you can see that the theory of design of experiments and the theory of analysis of variance, they will be going together. But now when I will be talking about this design of experiment, now you have understood that we are going to use this one-way, two-way analysis of variance. So, I believe and I assume that you have understood this concept. Now, in these cases when I am trying to discuss different types of designs, I will not be giving you the entire details of the analysis of variance, that how are you going to obtain the expressions. Why? Because we already have found those things in the earlier lecture. You have now learned that how to use the likelihood ratio test, how to use the principle of least squares, and how to use different types of statistical concept to find out the correct statistical tool. So, now this is up to you what you really want to do, and you have to take a call that which approach you want to follow. My objective will be here, I want to simply inform you here, well, this is the setup this is the way you are going to obtain the data, or you are going to conduct the experiment, and you are going to use here one-way analysis of variance or two-way analysis of variance or different types of analysis of variance. So, now I hope I have made it clear, and now we have understood that how are we going to move forward. Now, my emphasis will be on the structure of the design of experiment, that how are you going to collect the data and so on and so on. So, in this lecture, I will try to give you some idea about the basic definitions and terminologies and principles of designs of experiment. And once this terminology, these definitions are clear to you, after that it is not a difficult thing to understand those designs of experiments. And I believe that in case if I can explain you here a couple of this popular design of experiment, after that if you want to learn any more designs of experiment, or you want to conduct the analysis of variance in any other type of experimental conditions, you can very easily do it. So, now let us begin our lecture, and we try to understand the basic fundamental basic definition which are required to understand the experimental designs and their analysis. Okay, so, now the first question comes here, what is design of experiment? The design of experiment means how to design an experiment in the sense that how the observations or measurement should be obtained to answer a query in a valid, efficient and economical way. That is the same thing which I just explained you. And as I said, the designing of the experiment and the analysis of the obtained data, they are the inseparable parts of any analysis. And this is very obvious that if the experiment is designed properly, keeping in mind the question that we want to answer or the hypothesis that we want to verify, then the data generated is valid, and proper analysis of data provides the valid statistical inferences, and our objective is always to get the valid statistical inferences only. And on the other hand, if the experiment is not well designed, the validity of the statistical inferences is questionable and may be invalid also. So, it is very important for us to understand first the basic terminologies which are used in the setup of experimental design. And once we start handling the different types of experiments, then we will be talking only through this basic terminologies, right. And so, it is important for us to understand this basic language of the topic. So, the first definition is experimental unit. You see, whenever you are trying to conduct an experiment, you need some experimental material which is used on some experimental units. For example, when you are trying to conduct the medicine experiment, then you need some quantity of medicine which is going to be given to some patients. So, now in this case, the medicines are the experimental material which are given to some patients. So, those patients are the experimental units. So, for conducting an experiment, the experimental material is divided into smaller parts, and each part is referred to as an experimental unit. And the treatment is randomly assigned to the experimental units. What does this mean? And this term here, randomly assigned, it is very important in this definition. Now, if you try to recall your setup of analysis of variance, you always assume that Yij's, they are independent, right. So, now you want to ensure those things, and you do not want that there should be any type of hidden bias in the data which is trying to indicate a particular type of connection between the dose and the medicine. You do not have any hidden type of information that you want to implement, but you simply want to honestly judge what is really happening between the dose of medicine and the and the body temperature, right. So, next terminology here is experiment. So, this experiment is only a way of getting an answer to a question which the experiment wants to know. Suppose you want to know what is the effect of different doses of the medicine, and then there is here a treatment. What is here the treatment? Different objects or procedure which are to be compared in an experiment are called the treatment. For example, when you are trying to take different doses of medicine, 1 tablet, 2 tablet, 3 tablets, right, what are those things? Here in this case, the treatment is the medicine, right. You want to see what is the effect of this treatment on the experimental units, and then the definition of a sampling unit says that the object that is measured in an experiment is called the sampling unit, and this may be different from the experimental unit, right. If you try to see, whenever we are trying to do an experiment, we want to obtain some values of the study variable or the outcome variable which are going to be analyzed further. So, now the question here is this: when you are trying to give the treatment, then what are you really going to measure? For example, when you are trying to give the doses of the medicine to patients, you are trying to record the body temperature using a thermometer, right. So, the question is this: here in this case, the sampling unit is the patient on which you are trying to get the body temperature. Now, what is here a factor? A factor is a variable which is defining the categorization, right. So, for example, you have understood the factor A, factor B in the analysis of variance in the case of one way, two way, etc. So, and this factor can be fixed as well as this can be random, right. If you try to recall, we had taken a call that in this course, unless and until we are trying to say specifically that our factors are random, we are going to be assumed to be fixed, and yet time will come where we will also consider the random effects. Now, then the definition is for replication. What is this? It is simply the repetition of the experimental situation by replicating the experimental unit. For example, when you are trying to give say 1 tablet to a group of people, then what are you trying to do? You are trying to give the same treatment, that is 1 tablet to more than 1 patients. So, in simple words, I can say you are trying to repeat the experiment of giving 1 tablet to patient for certain number of times, and the certain number of times is the same as the total number of patients to whom you are trying to give the 1 tablet. And this replication is needed. Why this is needed? Because there will always be some random error and you want to minimize the random error. So, unless and until you try to take multiple observations, you cannot have an idea about the randomness involved in the observation. For example, the randomness in the body temperature can be because of say different body parameters. Somebody may have a blood pressure, somebody may not have a blood pressure, and their ages may be different. Somebody is say 33 years, somebody is 34 years, etc. Right. So, for that we always try to repeat the experiment, and this is called as replications. Then the terminology we have here, experimental error. So, the unexplained random part of the variation in any experiment is termed as experimental error. For example, if you try to take 2 patients of the same age, and if you try to give them the same dose of tablet, but still you will see there will be some difference in the time in which the medicine has brought the body temperature to a normal temperature. that can be due to various factors which are beyond our control. So, so that part is termed as experimental error. An estimate of experimental error can be obtained by replication, right. That is how we try to conduct this analysis of variance. How we are going to do it, that we will see. Then we have a definition of treatment design. A treatment design is the manner in which the levels of treatments are arranged in an experiment. For example, you are trying to say there is 1 tablet, 2 tablet, 3 tablets. So, these are the different levels of the treatment which are given in a specific way to some patient. For example, if there is a small child, you will not try to give that child a dose of say 3 tablets, because there is a risk that it may react, right. So, you try to say, okay, I am not going to give the 3 tablets to the young children. So, that is your decision which is going to impact the way you are trying to conduct the experiment, and this is indicated by the terminology of treatment design, right. And the question here is this: when we are trying to conduct this experiment and then the treatment design, they are in your control. Now, in case if I try to take here one simple example, suppose there is a food for the fish, and you want to know whether this food is going to increase the weight of the fish or not. So, what you will try to do, that you will try to take a couple of aquariums. Suppose I take 3 aquariums, and then we put a certain number of fishes into the aquarium, say 10 fishes, 15 fishes, 20 fishes, and then we try to give different doses of the fish food. Say in the aquarium 1 I give 100 grams, in aquarium 2 I give 200 grams, and in aquarium 3 I give 300 grams. Now, you have to see that how are you going to collect the observations from here. Remember, your objective is you want to see that how much this food has helped in increasing the weight of the fish. So, now if you try to see the structure, here is an aquarium, you will simply try to sprinkle the food on the surface of the water, and the fishes will come and they will try to eat the food. Now, at the end you will see that some food is there which if fish has not eaten. Now, my question is, how do you know that which of the fish has eaten what amount of food? Can you really know? This is practically very difficult. So, there is only one way out, that you try to hold the fish in your hand, try to do a tickling on the stomach of the fish, and then the fish will open the mouth and you try to put the food inside the mouth. That is the only way by which you can know that any particular fish has eaten what amount of food. But this is practically impossible, you cannot do it. So, now in this case, how are you going to obtain the observations? You cannot obtain the observations on the individual fishes. So, what we try to do? We try to observe the weight of the entire aquarium, and then whatever is the weight of the aquarium before giving the food, after giving the food, and so on that we try to collect the data. So, this is the treatment design, that you have designed it, that how the treatments have to be given and how are you going to collect the data, right. Okay. So, now if you try to see here that the same example I have given in the slide, that suppose that there are some varieties of fish food and we want to investigate on the effect of the food on some fishes. So, what we try to do, that the food is placed in the water tanks containing the fishes, and the response is the increase in the weight of the fish. So, the experimental unit here is the tank or the aquarium, and the treatment is applied to the tank, not to the fish, right. That is what you have to be very clear when you are trying to conduct the experiment. And you have to note that if the experiment had taken the fish in hand and placed the food in the mouth of the fish, then the fish would have been the experimental unit as long as each of the fish got an independent scoop of food. That is practically impossible. Right. So, now the question here is, what is now the design of experiment? So, one of the main objectives of designing an experiment is how to verify the hypothesis in an efficient and economical way. Right, and in the context of the null hypothesis of equality of several means of normal population having the same variances, that was the case what we have considered in the case of one-way, two-way analysis of variance. The analysis of variance technique can be used here. And now you can see when you are trying to apply here the analysis of variance technique, then such techniques are based on the certain statistical assumptions. And if these assumptions are violated, then the outcome of the test of a hypothesis then may also be faulty and the analysis of data may be meaningless. Right. So, the main question is now that how to obtain the data such that the assumptions are met and the data is readily available for the application of tools like analysis of variance, and this can be another statistical tool also. So, the designing of such a mechanism to obtain such data is achieved by the design of the experiment. Right. After obtaining the sufficient experimental unit, the treatments are allocated to the experimental units in a random fashion, and then we try to collect the observations, and then the design of experiment provides a method by which the treatments are placed at random on the experimental units in such a way that the responses are estimated with the utmost precision possible. So, there are three principles of experimental design, and these principles were developed by Sir R.A. Fisher, who is said to be the father of the statistics. And these three principles are the principles of randomization, principle of replication, and principle of local control. So, these are very simple thing, and the idea behind this principle is that you are going to obtain the statistical data from the experiment, which is applicable on the analysis of variance and other statistical tools. Right. Those assumptions are being satisfied by the way we are going to collect the data. So, now you know one of the basic assumptions in any statistical data is that they are something like IID, they are identically and independently distributed, or they are simply identically distributed, or they are independently distributed. So, among those type of specification, one of them is that the observations are independently distributed, and that is one of the basic assumption when we are trying to conduct the analysis of variance. We assume that Yij's they are independently distributed following a normal distribution with certain mean and certain variance. So, this principle of randomization helps us in getting the independent data, or it helps us in getting the data such that the basic assumption of independence of the observation is satisfied. Right. The principle of randomization involves the allocation of treatment to experimental unit at random. Right. And this is going to help us that it will try to avoid any type of bias in the experiment resulting from the influence of some extraneous unknown factor that may affect the experiment. Right. So, this is something like you say put say 20 this treatment inside the box, and then you try to hold the box and shake it, and so that you do not know that when you are trying to take out a chit from the box which of the treatment is going to be there. It is something like this. Right. So, in that case you can say that I have no hidden intention to draw a particular type of chit out of the box. Right. So, in that case we say that the chits with what we are going to draw from the box, they are independent. Right. So, in the development of analysis of variance, we assume that the errors are random and independent. So, this principle of randomization is going to help us in satisfying the assumption of independence of the observations or the independence of the random errors. And when this is satisfied, the observation also becomes random, and the principle of randomization is helping us in ensuring that this assumption is satisfied in the observation that we are going to obtain. Right. So, when we are trying to assign the treatments to the experimental units in a random way, then we have the following advantages. Right. It eliminates the systematic bias. Right. You cannot say that every time you are going to draw the chit which have got only the even numbers like 2, 4, 6, 8, etc. And we also believe, that is the basic fundamental of any statistical analysis, that we always assume that my sample is representative. That means all the characteristics which are present in the population, they are also present in the sample. Right. So, this principle of randomization helps us in getting a representative sample, and this helps in distributing the unknown variation due to the confounded variable throughout the experiment and breaks the confounding influence. Right. And this principle of randomization actually forms a basis of a valid experiment. But when we are talking of randomization, we also need the principle of replication to be adopted here, so that the observations are repeated, they are replicated, so that the results which are coming out of those experimental data, they are also valid. So, if the randomization process is such that every experimental unit has an equal chance of receiving each treatment, it is called as complete randomization. Right. That means the probability that any of the experimental unit is going to get any of the treatment, if this probability is the same for all the units, then we say this is the complete randomization. Right. So, now as we said, when we are trying to use the principle of randomization, we also need the principle of replication. Right. So, in the replication principle, any treatment is repeated a number of times to obtain a valid and more reliable estimate than which is possible with only one observation. Right. And this principle of replication helps us in providing us an efficient way of increasing the precision of an experiment. Right. That we know that the precision increases with the increase in the number of observations. As you try to take more observations, the variability of the estimator gets lowered, means under some statistical assumptions. For example, if you have got a an estimator like a sample mean, then we know the mean of the observation has got a variance which is like sigma square upon n. If every observation has got a variance sigma square. So, you can see that it depends on the value of n, means if you have more number of observation, this variance is going to be less. Right. So, replication provides more observation when the same treatment is used. So, ultimately it increases the precision or reduces the variability. For example, if you say if the variance of say some observation x is sigma square, then the variance of the sample mean based on small n number of observation is sigma square upon n. So, as n increases, this variance of x bar sigma square n decreases. Right. So, this is what we try to do with the replication, that the error in the observations can be controlled. Right. Now, the third principle here is the principle of local control, or this is also called as error control. Right. So, we have already used the principle of replication to reduce the experimental error, and now this principle of local control is used with the principle of replication, and that helps us in bringing the experimental error to be lower. Yeah, for example, if I say if the experimental units are divided into different groups such that they are homogeneous within the blocks, then the variation among the blocks is eliminated, and ideally the error component will contain the variation due to the treatments only, and this in turn is going to increase the efficiency. For example, we have considered that when we are trying to give different doses of the medicines, so now one option is this: you can choose any patient, either he or she is young or say older, and you give the medicine, or you first try to create a group of young children and then another group of elder people, and then you try to give the dose of medicine to these two groups. So now you can see here that in this case the variation due to the age factor within a group is as low as possible, right. Now, the last definition that we are going to consider in this lecture is the complete and incomplete block designs. Well, we are going to handle here two types of designs, and those designs are based on the construction of the block. So, that is why these experimental designs are also called as block designs, that we try to first create the blocks of the experimental unit and then we try to give the treatment, right. So, based on that we have an definition of complete block design and incomplete block design. That is very simple. So, in most of the experiment, the available experimental units are grouped into blocks having more or less identical characteristics to remove the blocking effect from the experimental error, and that is why such designs are also called as block designs. And the number of experimental units in a block is called as block size, that how many units are there inside the block. For example, you have created in the case of medicine 2 blocks, one say there are 5 young children in block 1 and there are say 20 elder people in the block 2. So, the block size is here 5 and 20 respectively. So, now in case the size of the block is the same as the number of treatments and each treatment is in each block is randomly allocated, then it is called as full replication and the design is called as complete block design, right. Means every treatment is given to every unit inside the block. And in case the number of treatment is so large that a full replication in each block may makes it too heterogeneous or it is expensive with respect to the characteristic under study, then smaller but homogeneous blocks can be used, right. For example, if there are suppose 40 levels of the treatment, then you need 40 people in every block. So, that may not be available. So, we would like to have say this less than 40 people in the block, right. So, in such a cases the blocks do not contain a full replicate of the treatments, and experimental designs with blocks containing an incomplete replication of the treatments are called incomplete block designs. That is all, right. So, now you can see here that in this lecture we have just understood what is the design of experiment and we have got some idea, and now I am sure that you should be convinced that whatever you are doing every day, that is also a design of experiment. You always try to prepare your schedule for study, that first you have to study this topic, then this topic, then this topic, and your objective is that you should get the maximum marks. For example, if you have tomorrow the examination of mathematics, today you are not going to study history in general way, yeah. So, now I have also explained you the basic terminologies which are involved in the construction of such experimental designs, and now we are going to use these terminologies whenever we are going to construct different types of designs of experiments. So, I request you that you please try to revise this concept, try to understand what are these definitions and terminologies, so that when we are talking about design of experiment you are comfortable. So, you try to practice it, revise it, and I will see you in the next lecture. Till then, goodbye.